Hi, good evening students. Today we are going to derive an expression for the de Broglie wavelength of a photon. First of all, what is meant by de Broglie wave? In the previous class I have explained matter waves. When material particles such as the electron, proton and the neutron are traveling with a certain velocity, then some waves are associated with these material particles. These waves are called as matter waves. As it was suggested by de Broglie, they are also called by the name de Broglie waves. Okay students, we have also studied at the beginning of this lesson that matter as well as radiation is playing a dual role. So light in some experiments like interference, diffraction and polarization behaves as waves, whereas the same light in Raman effect, Compton effect and photoelectric effect behaves like particles called as photons. So this light is playing a dual role, and in the high frequency region such as the X-rays and gamma rays, the photons are behaving like particles. In the low frequency range such as the infrared, microwaves and radio wave region, the same photons are the light behaves as waves. So there is some wavelength associated with the photon. So that wavelength only is called as the de Broglie wavelength. Now I will start with the expression for the energy of a photon. The energy of a photon E is given by what? H nu. Okay. Therefore, its momentum has the dimensions of what? The momentum P is having the dimension of energy divided by its velocity, where C is the velocity of the photon or C is the velocity of the light. So, energy is equal to h nu, momentum is equal to energy divided by velocity, that is h nu divided by C. But what is C equal to? C is equal to nu into lambda. This is expression relating the velocity, frequency and wavelength of light. So I am going to substitute in the denominator C equal to what? Nu lambda. Therefore, what is the momentum P is now equal to h nu divided by nu lambda. So this is equal to what? Nu lambda. So the factor nu is getting cancelled on both sides, or we get the expression the momentum P is equal to h by lambda. Okay, or the wavelength, the de Broglie wavelength, the de Broglie wavelength of the photon is now equal to what? H divided by P. So this is the expression for the de Broglie wavelength. So this is equation 1. Have you all understood, students? Now the same equation in the easy way I am going to derive. Okay. So I am going to compare the equations given by Max Planck and Albert Einstein. Now you see here, according to, okay. So according to Max Planck. So Max Planck is the propounder of which theory of light? Quantum theory of light. So according to Max Planck, the energy of the photon E is equal to h nu. So this I take it as the second equation. Then according to Einstein, the mass energy equation. Okay, according to Einstein's mass energy equation, E is also equal to what? M C square. So this is equation 3. I am going to relate the Maxwell's and Einstein's equation. So comparing 2 and 3 or equating 2 and 3, I will write M C square is equal to h nu. So h nu also can be written as what? By using this equation C equal to nu lambda, what is nu equal to C by lambda? So shall I substitute C by lambda here in place of nu? So this is equal to what? H C by lambda. So this square term and this C term is getting cancelled. So M into C is equal to h by lambda. So momentum is equal to h, that is a Planck's constant h divided by lambda. So this is the same equation, okay? Or I can take a left side, okay? Lambda is taken to the left side. So this is equal to what? H divided by P. So the same equation. So equation 4 and 1 are one and the same. This is how we are deriving the expression. Now what is this P? Momentum. Momentum P is equal to what? Mass into velocity. Is it not? So for material particle, for any material particle, say material particle means what? The proton, electron, neutron, like that. The matter is made up of these three fundamental particles mainly. So when these material particles are traveling with the velocity, they cannot travel at the velocity of light. So I am going to substitute. The velocity of the material particle cannot be equal to c. Therefore, I am going to substitute what? V for velocity. Therefore, for any material particle, the de Broglie wavelength is equal to what? H divided by m into V. So this is equation number 5. This is the de Broglie wavelength associated with any material particle which is traveling with a velocity v. Okay, students, I hope you must have understood. Next, we are going to derive an expression for the de Broglie wavelength of an electron. Okay.